Okay. All right. I'll do the introduction again. Good evening. My name is Wojuade. I'll be taking us on that control flows of teaching us what it is about. Before I get into control flows, how many of us were in the last session where counselor took us on um, data types, right?
Yes, sir.
How many of us were in the class in the last class or session? I think. Is it only David? Only David.
I don't think so.
Okay. Okay. So I just get right into it then. See, a conventional DAT program. We all know that that program is. Okay. Okay. You guys should try to keep the recording so you guys will be up to speed with that data types. So I just start. So control statements are used to control the flow of that program. Uh, that programs run. Let me. That programs run. Uh, can you guys give me a minute or a minute, 30 seconds? I need to. I'm not able to access that part, and that's I will be writing the codes we'll be using today. It's an issue with my internet provider, so I need to use a VPN. So I get tripped off for a minute. Okay, I think I'm back. Can anyone hear me?
Yes, sir.
Yes, we can hear you.
Yeah.
All right. So, as I was saying, control flow statements are statements that we use to control the flow of our programming language, of our program, of our program. Uh, normal, Normally, that program flows from left to right, top to bottom. Okay, it flows from. Can you guys see my screen? I'm trying to present. Can you guys see my screen?
Yes, we can.
Yeah, we can see it.
Okay, so as I was saying, that program flows from left to right, top to bottom. Let me show. Let me just show a real life program. So it flows from left to right, top to bottom. The Everything you write, the compiler understands it by or executes it by flowing from left to right, top to bottom, just like that. So, and if something is flowing like that, we as programmers, what we want to do is imitate we want to imitate the behavior. We want to try to bend the computer to our will. We want to make the program do what we want it to do. And if it is flowing from left to right, top to bottom, it becomes very. There is a need for us to control um, how it is flowing, so we can decide to make the program execute a particular line of code based on some conditions, right? So these statements are very important. It's in every programming language. These statements are very important in any programming language. It is used to decide whether a statement will be executed or not. As I was saying, the Dart compiler interprets code from left to right, top to bottom. So in a standard Dart program, we all know that the main function is the entry point of a standard Dart program. So every code I write inside this main function will run left, right, up to bottom unless I'm putting some decisions to make it um, not run like that. Yeah. Like for example, if you are trying to build a program, say you are trying to take yourself as a program, for example now, and you are let's say you are eating, you continue eating until you are full, then you stop eating. So there is a condition there. There is a kind of condition where what that makes you stop eating when you are full. I don't know if you guys understand the explanation I'm trying to give. Can someone just unmute to let me know you guys are following because I feel like I'm rambling here. Hello.
Yeah, we are continue.
Okay.
I'm understanding what you're saying.
Okay. Okay. Thank you for that. So by using control flow statements, a Dart program can be altered, redirected, or repeated based on the application logic, based on the product need, the application are trying to be based on the need of it. So as I was saying, we are trying to imitate a behavior, we are trying to create, we are trying to control something. So we need to control flow statements to help us do that. Uh, so we can classify control statements into three. We have the decision making statements. Let me just write it here. Making statements, looping statements, and jump statements. Alright, so decision making statements allow us to determine which statement to execute based on a test expression at runtime. What decision making statements help us to do is help us make a decision, just like the name says, it helps us to make a decision. And in that program, in that program, okay, I don't understand what this one is saying, but as I was saying, decision statement help us to make a decision, and looping statement, as the name says, helps us to repeat a particular behavior based on a condition, and jump statement basically helps us to break out of a function or to break out of a function or continue a loop like that. Have you guys done anything on functions?
No.
Okay, okay.
Yes, no. Yes, we don't come to function because the word name is a function. But to start the program, the command we use to call this is the function itself. To start the function, so it's not function. But
Okay.
not in detail.
Yeah,
Not
yeah,
in detail.
I get that. You've not done it in details. Okay, so I'll just try to not scatter anything and just continue like this. So we have different type of decision making statements. We have the common if statements. We have the common if statement, the if else. So I mean, these ones are just basically the same symbol. If else statements, and let me say the switch statements. Can you please unmute? Can you please mute your mic? It's interfering. Thank you. Okay, so for looping statements, we have a few types of looping statements. You have the for loop, the for in loop, and we have the while loop also. We also have something called do while loop. And then for jump statements, we have these statements are basically used to jump from one statement to another. You can say like it transfers execution of one statement to another. You'll be surprised how often we might need that. And for jump statements, under this category, we have the break statements and the continue statements. So you'll be taking these guys. How many are they? 1, 2, 3, 4, 5, 6, 7, 8. So we're going through these 8 statements, 8 types of control flow statements in this class. So just stay with me. If I'm moving too fast, or if you need me to, if you don't understand anything I have said, please feel free to throw me back. Okay, so let's start with the first one, decision making statements and if statements. So, sorry. Okay. So what an if statement allows us to execute a block of code when a given condition returns true. I think you guys have already done operators where um, a certain expression can evaluate to a Boolean value, true or false. So what if statement does is that it helps us to execute a particular code based on the condition. So for example, let me first of all give us the let's say the anatomy of an if statement. So this is it. If condition, then statement that you want to execute. Okay, so what this statement basically does is that if this condition evaluates to true, it will run all the code you put inside this curly braces, this block. Right, so let's try to run something. Let me put all this outside me. So see the code, right? So for given this block of code now, then okay, equals to 8. And this is just like the most common example. So we all know that the main is the entry point. I am trying to demonstrate what I said earlier about a Dart program running from left to right, top to bottom. So you get the drift, sha. So normally, okay, let me put, is this possible here? If you run this particular line of code, this will run first, then this, then this, then this, then this. Let's see that. Okay. Hold on. Right, just like I said, the first line, print starting main will run first, then print hello world will run, then print third line will run, then print age. So if you want to make a decision on whether or not to print age, right, you can, that's where you can use if statements. So for example, we can just easily say if age is less than 18, um, print age, right? Then let me put a continue here. Continue, right? So if you run this code now, you'll get you'll notice that the last the age is not being printed, right? Because of this control statement that we have here, we are able to change the behavior, the normal behavior of the Dart compiler. The Dart compiler was able to see this expression and decide whether or not to run the program, the statements inside the block. So it basically ran this first line, starting main, then ran hello world, then ran third line, then assigned 18 to this variable age. Then it's not like it's going to skip this, it's actually evaluated this, then decided not to run it based on the condition. This is the condition, based on the condition we've given the compiler. So it was able to make a decision and jump this statement, this print age statement. So let me try to make this example more robust. Uh, okay, looking for a way to make this example more robust. Print the legal age in Nigeria is 18, right? So if age is less than, if age is equals to, less than is okay. So instead of just printing this, we can just say user cannot. Okay. So Say, for example, you were told to write a program that helps to filter users, citizens, basically. Say you are employed by INEC to write a class program that helps to check or to check if a particular person is eligible to register for PVC. This is as simple as it's going to be. You will just check for the user's age and see if the user is less than 18. Um, so say for example, this particular user is 12 years old, and then we run this. I don't think we'll be needing this anymore. We'll not be needing all these print statements anymore. So cancel, clear this, clear this. Alright, so remember left to right, top to bottom. So if you run this, if when you run the program, we get this line of code. That's basically, this is because this particular expression here, age less than 18, it evaluates to true. It evaluates to true, yeah. Because age is 12, 12 is less than 18, so it's true. Then this statement gets run. To confirm that this particular evaluation is actually running, you can do this, right? So the value of this expression will be returned into this place, into condition. So you can easily just say if condition, if condition, then it's going to give us that. It's still going to give us the same answer, right? So coming to the next one, if else is so we are still using the same scenario. You want to write a program that registers people for PVC, that checks um if they are if they are eligible to get a voter's card. So you've answered one condition: if the user is less than 18, right? The user cannot get the PVC. So you want to, in most cases, you want to cater for the other scenario. For example, for if this condition evaluates to false, what should run? That's where that's where the need for if else statement comes in. We have if else statements, and we have the if else statement and the structure. Let me take another one. Anatomy, I'll check the right English when the session is over. The anatomy is basically like this: a normal classic if statement, but the um, addition to it is an else block. We have this, then we have, yeah, okay. So when if the condition is true, if the user is less than 18, we proceed to register user, right? But if the user is um, greater than 18 or is 18 or 18 above, a certain program should also run. So that's why we need the else statement. So what the else statement basically does is that when this condition evaluates to false, when this expression evaluates to false, the program written inside the if block is skipped, and the program in the else block is going to run. I've been using block. Do we know what block is? A block of code. Can someone unmute and let me know if we know what block means, or if you need me to explain what block means? Okay, so first of all, are you trying to say something?
It just, how I put it, it's more like an instruction to a computer, a block of code of an instruction, more like how I define it. Just a particular line of an instruction. You understand? So
Yeah.
that's not the line of code. It's more like line. Each line represents an instruction. So that's all I think I'm trying to
Okay.
agree for.
Thank you for that effort. Like I said earlier, someone else wants to try.
Yeah. For me, I feel maybe best way for me to explain it is an indented code, where code is arranged in a particular order that it will be more easier for the developer to trace a line of code with errors or something like that.
Yeah, thank you guys. You guys were close. You guys have the idea. You guys get the idea of blocks of code, block. When I say block, I mean this, so like ice block, right? So, like I said earlier, if I mention any jargons that we do not understand, please just tell me so I can explain it. So, a block of code is basically a group of code, like Festus and I didn't get Michael has said. But Michael said is indented. You don't need in that because this is not Python. You don't need it to um it does not need to be indented for it to be a block of code. So when you say block, just think of block as a block of code as a group of code. Yeah, I think that's it. Let me get you guys a more robust definition. Okay. Like this does it. This satisfies our use case. Uh, okay, you don't need this. Does not need a certain condition does not need to be met for a block of code to be a block of code. So it's just a group of code, right? Composed of several statements, multiple statements that are intended to execute. So the way me I see it, the way I look at blocks of code, the way I understand it is that when you see two curly braces, everything, all the statements of code in between the two curly braces are a block of code. So in this main statement now, in this main function, all this, each line, this is a statement, this is a statement, this is a condition, this is a control statement, this is a statement, this is a statement. Everything here is a block of code. If you dive deeper to inside this if statements, this is also another separate block of code. Do you get that? So just think of block of code as any statement in between two curly braces. Are we clear on that? So as I was saying,
Yeah.
Sorry, can you please repeat it again? Any, the way you said it. Any
Instead
statement
of
between
two curly braces, statements between two curly braces, you can refer to them as a block of code. Is that clear? But if you want to um, say, let's say, orthodox definition of a block of code is this thing that we got from the web, right? But the orthodox is not the one that always sticks. You we need to have mental maps that helps us to um, quickly understand and retrieve information we are storing. So a way to just see it is that when you see two curly braces, the statements, line of codes inside the two curly braces are your is your block of code. So in this main function, like I was saying, we have this block of code. Then we also have this block of code. You guys are saying my highlighting, right?
yes,
Anybody?
yes,
Okay,
yeah, they're
okay.
nice.
Because I'm saying
Yeah.
this. Okay. I'll try to be more descriptive. So as I was saying, we are on if else statements. So what the if else statement does is we have the normal if statement that does not change. That's still what it is. If statement when the condition given to it, when it evaluates to true, it runs the statement in its block. Right? It runs the block of code. Yeah. And then so what if else statement basically is just a normal if statement and an else block. So what the else just does is that it helps you to undo the other condition. For example, earlier we've been using this voters card scenario, um, age scenario, less than 18, right? So this particular program it tells us if age is less than 18, print this stuff, this statement. User cannot get PVC and proceed to register user, right? But it does not say anything if the user is greater than if the user's age is 18 or greater than 18. So that's where the else block comes in. So what the else block would do is run when basically just look at the else block as the else block will run when the if statement fails, when the condition in the if statement fails. Like there is this particular image. I think I saw it on Java point. I saw it on Java point. Right. 1 second. Basically explains you an image you explain it better. Right. This is it. This is an if else flow, a diagram of it. The program starts if condition is true, it runs the body of the condition, the body of the if statement, and if it is false, it runs the body of the um else statement. Do you get that? So this one runs when condition is false. Do we get that? Is anything confusing at this point? Okay, nothing's confusing. So an
It's
example,
clear.
yeah, thank you. An example will be this thing we'll be using. Okay, age of user one, age of user two. I don't need that. Okay, so age of user is okay. Don't need age of user two just yet. Right. So we are still on decision making statements, and we are currently addressing if your statement. And we have this particular user of age 12 that's trying to register for a PVC, and we are trying to write a program that handles such user. Okay, so we've handled for the case where the user is less than 18, and then we need to handle for the case where the user is not is greater than 18, or where this particular expression evaluates to false. So when this statement evaluates to false, we this else block will run. So if you put in here that so who registers voters who registers voters okay, proceed to register. That works. Okay. So these else statements, like the if statement, can also be multiple lines of code. It can be as long as you want, as long as they are inside these two curly braces. They are just a block of code. So like that, sure. Age of user is 12. So if age of user now is 20, say 20-year-old user wants to use our program now, and the user imputed their age as 20, the else block is supposed to run because this particular expression will evaluate to false, right? So the if statement is nothing too big. It's just a the if else statement is just catering for when your expression fails, because it's not. You can look at it in this from this perspective that it is not good user experience to not say, for example, we don't have this, and then we run this. A 20-year-old user wants to use our platform, and we are not telling the user anything based on the age. So we are not doing anything based on the age. So we need the else statement to cater for users greater than 18. If I'm going to structure this code, I think the best way would be to change this guy to be if it's 18. So I'm just swapping it out. Swapping it out. Okay. So what I just did is not very important like that. It's just how do I put this? It's just easier for me to read like this. So if user is greater or if user is 18 or greater than 18, the user should proceed to the registrar to um, put down their details. If not, the user should go back home, basically. So that's if else statements. So this statement is used when you have two conditions and um, you want to run a particular code based on either conditions. Do you get that?
Yes.
Oh, thank you. Okay, so we have going to the next one. Time is moving faster. The if else if. Okay. We also have one that is that's the if else if. It is basically just addition of these guys. So let's look closer here. This particular else statement runs immediately the if statement evaluates to false, right? But say for example now, imagine 18-year-olds are not allowed to vote. Uh, no, that's not good. Let me think of something. Give me a minute. I'm not able to come up with a better example. But just imagine you have three conditions now. You want to make a decision between three conditions, right? And this will not cater for it. Say, for example, we have another condition where 18-year-olds are supposed to visit registrar A and um, users greater than 18, that means 19 upwards, are supposed to visit um, the registrar too. That kind of filter registrar. This particular control statement does not cater for that. So that's why we have the if else if statements. So we are basically just adding another if statement, right? Just like normal casual English language. If user is greater than 18, proceed to registrar A. Right? Else, right? We haven't catered for if the user is actually 18. Okay, we'll put this here first. If user is equal to 18, and if user is greater than 18. So else if this age of user, and I choose this long here. Age of user is this. Okay, friends. Please, if you are confused at any point, feel free to call me back. Right. So the only thing that I changed here is that our Oga said maybe to make things faster, 18-year-olds are more than people, 18-year-olds, maybe they have the priority, and Registrar A has some particular things that Registrar A will do for 18-year-olds, right? So we need to filter through and direct 18-year-old users to the Registrar A. And the formal statements we had was basically this, right? So we added this. So we are just basically adding another if statement to the previous if statements we have, so we can easily cater three for three um for three
Okay.
conditions.
I'd
Hello?
say best way to put the people that just turned 18 So the chances of them not having a voter's card at all is high. But the people that are greater than 18, they have chances of maybe they have registered for a voter's card before, maybe
Yes.
temporary or something like that.
Yeah, so maybe thank you very much for that. So say maybe people older than 18, maybe they just want to reprint or something, or maybe they just want to reprint because they have their voter card already and maybe it's got lost or something. But 18-year-olds have they are likely to have never they are likely to not have a voter card at all. So that's a use case for this. You'll find plenty more use case for this control statement when you start practicing on your own and that start flutter sha. Yeah, so with this, so imagine now we are not more using the voters card now. Imagine we have five conditions, five different registrars, and we have different age groups. Say 18, 19-year-olds to register, say um 20-year-olds to register this. Let me give an example of that. I've not run this code. Let me run this code. So just if user is 12, what's going to run is this statement because mm, because this evaluated to false and this also evaluated to false. So the else block run. If user is 18, if user is 18, this runs. The first if block register it, the user proceeds to register it. And if user is greater than 18, which is say 20, the user should go to registrar B. Yeah. So a common mistake in this place is that if we um a common mistake, I'm saying it's common because I've made such mistakes before. If remember, like I said, left to right, top to bottom, left to right, then top to bottom. So in this case, the code is running top to bottom. That means this expression runs first, right? This condition is first checked. If this condition is true, right, as we've seen when the user was 18, this line of code will run and all this will not run sha. Let me give a simple explanation to that. If I was using if you guys can see this bottom right corner of my screen, because I did not give the compiler a condition, I just gave it true. The compiler is complaining that dead code. What is basically telling us that once any of this in this block of code, this if block, if else if block, right? Once any once any if block evaluates to true, it's going to skip the remaining. Do you get that?
Yes.
Yes.
So yeah, so once any if statement evaluates to true, it's going to skip the rest. Thank you for getting that. So as I was saying, imagine we have five more conditions we want to go through because I'm not feeling very creative this evening. I'm not able to come up with interesting examples. Yeah. So just bear with me and try to keep up else. So what I basically did is just copy and paste this particular condition. So 18, 19, 20, 21, 22, 23. 24 and 25, right? So we have different packages for these age groups, for these ages 19, 20, 21, 22. And when we started, what our guy said was to filter out people that were less than 18. Now we have how many conditions? 1, 2, 3, 18 to 25. That's like 7 conditions. You have that much conditions. So we keep expanding this code we've written before. And this, if you agree with me, this is kind of hard to follow, hard to read. If you are going to read through this code, you have to first go through this, go through this, go through this. Like go through 7 different conditions before getting it. I think that's why we now have a switch statement. So my own rule of thumb is when you start having up to 3 to 4 conditions, for 3 to 4 different conditions, then you should use a switch statement. So switch statements are also decision making statements. Basically, I think you have to switch to Java point again. If you want to get or read more about all I've been saying, please go to javapoint.com. It explains basically. I basically prepared for this class using this website. So the flow diagram for if else if statements that I just explained. This is it. If condition is true, statements. If condition 1 is true, statement 1 will run. If it is false, then it will evaluate condition 2. If condition 2 is true, statement 2 will run. But if it is false, it's going to evaluate condition n. If condition n is false, it's going to get to that false else block, right, and run that else block. But if it is true, it's going to run the statement n. But it is kind of hard to follow, like I said, when you start having plenty conditions. So the switch statement, the flow chart is basically the same. What changes is the flow chart is the same, the use case is the same. We're having multiple expressions and you want to run different, you have multiple conditions and you want to run different statements based on the conditions you have, right? So like you said, is switch statement is used to avoid the long chain, like I said, long chain of the if else statements. I said earlier that my rule of thumb is when you have 3 conditions, when you have more than 3 conditions, then you start thinking of doing a using a switch statement. Thank you. So I just get for us the anatomy for a switch statement. It works exactly like an if else if statement. I'll paste this here, then comment it out. So because I'm not using an ID, I'm basically using yeah. Comment this guy out because we are moving to this. So a switch statement, like I said, basically the same as if else if statement, and this is the template. I'm looking for the English, I've not found it. Then you open that block, the switch block, page of user, I must spell this correctly. Page of user, then we have several cases. So looking at this example where we have different packages for different ages. So what switch statement take it does not take any unlike if statement that takes a condition. All it takes is an expression. It does not take a statement that evaluates a result. Do you understand that? Like it does not take a condition, right?
You understand? It does not take expression, a comparison expression.
Yeah, thank you for that. It does not take a comparison expression. Thank you so much for that. So all it takes is just, in this case, it takes the age of the user. Then we will supply the block, the switch block, different conditions. So when a match is formed, right, it's going to run the statements in that block. So this is it. Case. Okay, so let me just give us the full example. Case 18. Case 18 has its own block, then a break statement. Because of switch statements, we will be jumping to these guys, the jump statements. So I'll have to explain what the break here does and why it is important. So case user is 20, case user is 19, break, case user is 20, break, case user is 21, break. You get the drift like that, yeah? Then it defaults here. So it defaults, ratio will be semicolon. Default will be this. So I will explain as it as they go. Right. So when user is what the switch statement does is it takes this expression that it gives to it, that it gave to it, and it evaluates it against its own the cases you've given to it. Do you get that? So it takes age of user, which is 20, evaluates it against 18. If it is true, if it matches, then it's going to run 18. Evaluate it against 19. If it matches, it's going to run 19. It's going to run statement for 19. I'm tired of writing print statements. So please, I'll try. Time is moving. I was thinking we'll be done in 2 hours. I'm almost used a whole hour on decision making statements alone. So I'll spend less time trying to be creative. Okay. Proceed to default case. Default case, just take your default case as your normal cut this. Okay, so the thing with switch statements is that it goes through the same intuitive process of left to right, top to bottom. It goes through the same process, not changing for a switch statement. So what it does is takes this, matches it with the fourth case. If it's true, it runs the program in the fourth case. It takes this, matches it takes the age again, matches it with 19, the second case, and runs the block of code near it. So we have this break statement. So now, if we run this code, this is going to be the line that's going to run because user is 20 and it's going to run this. Is yeah, extra 20. So let me explain what it did. It evaluated this false, so it skipped it. Evaluated this false, it skipped it. Matched with this true, so it ran it. So the thing is, why we're having break here, what break statement does is that it will execute all cases, right? So for example, if you remove this break statement now, when it's finished running this block of code, right, on a normal switch statement, it's going to continue to this and run every other thing down. So say if user is 18 now, it's going to run this, right? But the fact that because it's ran this does not mean that it does not want to run the rest. The break statement is what is stopping it from running the rest. If you remove the break statement, it's going to throw an error. I wasn't expecting that. Okay, it's going to just continue. So the break statements, that's just part of why that is going to use. Going to tell you, the compiler is going to tell you when you are about to make a mistake. So the break statement is essential. Oh boy. The break statement is essential to stop the switch statement from running other cases as soon as what it is looking for is matched. Do you understand switch statement? Okay, there is a very interesting example here on Java front. If I am correct. Yep, a row number program. Let me just copy it and just run this for us. Yes, do you understand switch statement or do you need me to explain again? It's awfully quiet.
I understand the switch statement is very clear to me.
Okay, thank you. Anybody else? Can I get two more people? Can I get two more people? Okay,
Yes, yes, clear, it's clear.
can I get anybody, just one person that does not understand? 5 seconds. Five, four, three, two, one. Okay. I'll assume everybody understands the switch statements. So I'll just go through this briefly. Like I said, my explanation here is not very relatable. So there's this one on Java points. So there is this variable row number, right? And then the switch statement. So just like for matric number now, if you are calling your matric number, that's basically what it is. So we give the switch statement the row number. Let's make it more relatable to us. We take the example and make it more relatable to us. Matric number, the row number, right? So once you call your matric, once it's going to take your matric number and all the cases it is given, then the statement here will run. We did not put it inside blocks. I I like using curly braces so I can easily know where a block of code starts and where it stops from, and where it starts from and where it stops. Yeah, branch. That's nice. So yeah, I realized that I did not explain the default statement very well. So if everything, all the cases, I said it takes what you gives it here in this expression, and then it matches it to all the cases you've supplied. So in the case where you did not supply any, where it did not match anything, that's when the default block of code runs. The default block, if you don't add the default block, the compiler will complain. So whenever you're having a switch statement, you always have to put the default block. That's where I got my own rule of thumb of you have three. When you have more than three, that means you have four. So you put three cases here, and then your fourth one will be your default. Do you get that? So the default line, default block runs. If the expression does not match any of the cases, I think this is better here. Let's run this serious for an sake. 901. That's even better. Can anybody tell me what this? Let's look at this line of code. Since we all understand, can you tell us which block of code is going to run quickly? What's going to be the result of this block if you run it? This
The
code,
default will run.
The, the,
the default
the
run.
default,
Okay.
default, the
Thank
default.
you. Thank you so much for that. That means you are following. Yeah, the default run. I would get that. Oh, sorry, this is not where I want to put it. I want to put it. I'm trying as much as possible to compile a Jota note. So default. Let's put it here. So it can. I don't. After the class, I will try to make it more um readable. But for now, we move on. Everybody understands why the default to run, right? 5, 4, 3, 2, 1. Okay, everybody understands. So the default to run because this given matrix number 90014 does not match any of the cases given. That's just like that. I will comment this one out again. Switch Java points. Like I said, I will take time after this class to um, give us a better note or jotting, like a cheat sheet. Okay, so we've been able to cover all the decision making statements, and thankfully, everybody says they understand. So we'll go to, and also because we were going through switch statements, we were able to do this guy break statements. We've been able to do this guy, been able to do this, been able to do this, been able to do this. Then this brings us to the looping statements. Looping statements like this. What's this guy saying? Okay. Looping statements. Let me try to pull it up. The definition. Okay. So we use loops. In my own mental map, I'll get you guys the definition, but the way I reason about loops is to loop through something, to run a code repetitively, to run a code. Yeah, okay. This explains it very well. That loops is used to run a block of code repetitively for a given number of times or until it matches certain conditions. So if you are going to use loops very well, you need to kind of understand if your decision making statement because if the loop statement will run continuously and to keep running, right, until a condition is met. So we are using a decision making statement to kind of control a loop. Do we get that? I think that's kind of easy enough to get. Sorry. First of all, so moving to loop statements, right? Loop. I'm tired. Okay. We have another main. We have four loops, four kind of loop statements. We have this. I might move a little bit faster here, but that's because I'm looking at the time. But if you don't understand anything, draw me back. Okay, so we have four loops, four kind of looping statements, and like I said, used to run line of code repetitively. Let me dub their explanation, their definition here. I'll put it here for us, not right. It runs a line of code, it runs a particular statement, a block of code repetitively until a condition is met. I don't like this repetitively until a condition is met. I think it is. Yep, that's better. If you prefer the Java points, you can always get it. But I think this is better. It's shorter and says the same thing. It's even kind of more correct, as you will see. Moving on. So let's pick the for loop. And the anatomy for a for loop is for we have initialization, condition, and increments or decrease. Normally, modern day programming, we rarely use for loops like this, but this is for loop in its rawest state. So you want to use a for loop, the very so for example now we want to run a particular block of code multiple times. So you want to print hello world 25 times. You can go like this. Right. Then we can go the let's say this is the most for a layman, this is basically what you just do. Not run 25 times, so just paste it, copy and paste it 25 times. But just like if else statements, why we needed switch statements when we have if else statements, this is kind of hard to read. You have to start, it's hard to read, hard to keep up with. You have to be turned on mentally to count, to be sure that it's correct. But with for loops, we can just run this particular block of code multiple times as much as once. So say for 1 million times, you can't keep printing, you can't keep copying and pasting for 1 million times. So what for loop does is for this initialization, so we say int I, this is just the inside I is, that's the initialization, inside I is equals to 0, I less than, for condition, I less than 6, and increment and decrement I plus plus. So what this particular line of code is going to do is, it's going to run print hello world 5 times. I'll explain why it is 5 times just after I confirm I've not said rubbish. It should run 5 times. Oh, it should run 6 times because you're starting from 0. So 0, 1, 2, 3, 4, 5. So this can be kind of confusing or hard to keep up with. So let me try something by initialization. I've not done this before. I don't want to try. I'll just look at it in this way. Yeah, okay, it can't work like that. But condition can actually restrict off. But can't restrict off because we need this. Yeah, initialization can be stripped off in a way. We put it here, right? So this is initialization condition increments or decrements is going to be here. Yeah, increment and decrement is just here. I'm trying to break it down to the simplest part. So what the for loop does in its raw state is that it initializes a variable. We initialize variable I and we make variable I is equals to 0, and then we give the for loop a particular condition that I is less than 6, and then we tell the for loop to increment I plus plus. So what it does is I is equals to 0, so it checks this condition, excuse me, check this condition. If I is less than 6, it jumps into the block of code and executes the block of code, and then it executes this last. It increases I by 1, right? Let me interpolate this and so it does the same thing. So once it increments I by 1, I is now, I that was 0 before is now 1, right? It evaluates this condition. Since it has initialized, it's going to go to initialization just once. Since it has initialized, it's going to jump to the condition. I is still less than 6. That's true. It's going to run this, and it's going to increase I by 1 again because of this expression put here. Then I is less than, I is still less than 6 because I is now 2. It's going to, since I is less than 6, it's going to run. So like that, like that, like that, until we get to the condition. So when I is 5 now, we get to I is 5, I is less than 6, 5 is less than 6, it prints this I plus plus. Now I is 6, then it goes through this condition again. I is less than 6, no, 6 is 6 less than 6, no, so it skips the the loop block and continues executing until this. So stay immediately the compiler sees a loop, a for loop, right? A for statement. It runs it multiple times until this condition is false.
until this condition is false before it continues on to the next line. Java 20 will have a flow for us, I'm very sure. Yeah, that's good. They don't have a flow. They don't have a flow for us today. Yep. They do. This is the flowchart for a for loop. Initialization checks for condition. If condition is true, it runs the incrementation, it runs the loop body. It does the incrementation and decrementation, then checks for the condition again until the condition evaluates to false. Right? That's when it's going to stop and continue to the next line. So in this case here, we will have this. You see, it's actually ran until the condition until I equals to 6. That's when it was able to continue after loop. Do we get that? Do you get that? I need someone to respond.
I
Yes.
understand it.
Yeah, so because of time, we still have some statements to go through, and I'm looking at the time now, it's almost 8, and also I'm tired. So I would stop the class here. I'll ask you guys to come back tomorrow, same time, 6 o'clock, so we can conclude on control flows. Is that okay? You guys be able to make it tomorrow.
All right, no problem.
I'm doing this so that the amount of time we spent on it won't be logical to spend almost an hour explaining decision making statements and just brush through looping statements in 30 minutes. And I can't even continue with that energy I started with even like
I
this.
understand. I understand.
So what's going to happen
Tomorrow.
now? Huh?
Okay, now.
Yes,
Tomorrow.
tomorrow. Yeah, but don't leave yet. We we are concluded that we'll come back here tomorrow to conclude on the control statements. If you have extra time on your hands, you can go through Java's points just to prepare for what's for tomorrow, right? And then the assignment I prepared sadly has four loops in it, so I have to come up with another one that's just basically decision making statements. I will relate with Samuel and Samuel would give the assignment to you guys before the day ends, before 12 p.m. Is that cool?
That was funny.
Yeah, thank you. So Samuel, I'm done for today. I'll be taking this beautiful thing again tomorrow to conclude on control statements. Like
Okay. Okay. So what time will that be?
same time, 6 o'clock. 6 o'clock
Sorry,
tomorrow.
sorry. I thought I'm already on mute before. Yeah, Wojade, thank you very much. What time will you be having this lecture tomorrow?
6 o'clock tomorrow. Six
Sorry,
o'clock.
what is it? 6 o'clock.
6 o'clock tomorrow.
Okay. So will you guys be able to join the call 6 o'clock tomorrow?
Yes, yes, yes.
Okay. Okay. No
Thank
problem.
you.
I'm available by 6. Yeah.
Alright.
Yeah. Welcome. So thank you very much, Wojade, for the section. I believe we all get one or two stuff. Yeah, I know the tomorrow lecture now is not like an official one per se, but it's just like a completion of today's section. So we'll be having the 6 o'clock class tomorrow, and also the next class will be on Thursday, where we'll be having another topic and another instructor. Then on Friday also by 6 p.m. So I believe we all get something out of this particular session. So the recording will be uploaded on the YouTube channel. I believe do we all get the links to the video